transforming business with cloud AI, unlocking opportunities and challenges. With their vast resources and expertise, hyperscalers are the architects of the AI revolution, redefining how businesses will operate and thrive. They are also creating tremendous opportunities that many business leaders are only just beginning to explore. The market for AI services reached $200 billion in 2023 and is expected to expand to around $2 trillion by 2028. Creating an AI model like ChatGPT on-premise requires immense processing power, storage, and specialized skills, with costs skyrocketing due to hardware, infrastructure, and maintenance. The scale of resources required to train a model of this magnitude is staggering. GPT-4 itself was trained with 1.8 trillion parameters, requiring the use of around 10,000 high-performance GPUs, such as NVIDIA's B100. Alongside the GPUs, training large-scale AI models also demands 300 petabytes of storage to accommodate the vast datasets and outputs generated during training. The cost of this infrastructure quickly adds up, pushing the total investment for a single training cycle to nearly $500 million US. This figure includes the costs of GPUs, storage, electricity, and the additional infrastructure needed to support such a complex system. Moreover, organizations would need specialized talent to manage and maintain these systems, further increasing operational costs. Considering that training often requires multiple cycles, epochs, the total cost of fully training such models can rise to $5 billion to $10 billion USD, depending on the number of training cycles needed. Given these challenges, hyperscalers like AWS, Azure, and Google Cloud provide a more accessible and cost-effective solution for running large-scale AI workloads. By leveraging cloud services, businesses can access the necessary compute and storage without the massive upfront costs and complexities of on-premise infrastructure. Artificial intelligence, or AI, refers to the capability of machines to mimic human intelligence. This can range from simple automation tasks to more complex decision-making processes that resemble human reasoning. Machine learning, a subset of AI, takes this a step further by enabling machines to learn from data. Rather than being explicitly programmed for every task, machine learning systems use algorithms to identify patterns, make predictions, and continuously improve based on the data they process. In short, while AI encompasses the broader goal of creating intelligent machines, machine learning is one of the primary methods through which AI systems achieve this intelligence by learning from experience. In the AI and ML landscape, we typically classify models based on how they learn and are applied. The most widely recognized types are supervised learning, unsupervised learning, reinforcement learning, and generative AI. Let's explore each of these categories with real-world examples. We will start by explaining the stages of supervised AI training using the example of training a model to detect human heads. The first stage involves gathering labeled data specifically for detecting human heads, consisting of images where heads are clearly identified. Accurate labeling is crucial to ensure the model learns effectively from high-quality examples. Next, a suitable supervised learning algorithm is selected for image recognition. This algorithm will learn to associate features in the images with the corresponding labels indicating human heads. In the training stage, the labeled images are fed into the algorithm, allowing the model to adjust its parameters and minimize prediction errors related to head detection. After training, the model is evaluated using a separate test set of unseen images. This assessment determines the model's accuracy in detecting human heads and its ability to generalize. Following evaluation, the model enters the tuning stage, where adjustments are made to enhance performance. This may involve fine-tuning hyperparameters based on evaluation results. With the model refined, the cycle begins anew. The trained model can be retrained with additional labeled images, followed by re-evaluation for continuous improvement. This iterative process enables the development of a more accurate and robust head detection model over time. Now, we will explore the stages of unsupervised AI training using the example of detecting customer microsegmentation. The process begins with gathering unlabeled data from customer transactions. This data consists of various customer interactions and behaviors, but lacks predefined categories. Next, visualization techniques are applied to the data. This step helps in understanding the data's structure and identifying potential patterns, guiding the analysis that follows. An unsupervised learning algorithm is then employed to analyze the data. This algorithm looks for inherent groupings or clusters among customers based on their attributes, revealing insights into their behaviors. After clustering, the results are evaluated subjectively by experts. They assess the identified segments to ensure they are meaningful and useful for business applications, determining the practicality of the microsegments. Once the evaluation is complete, the microsegments are defined. Each segment represents a unique group of customers with similar traits, allowing for targeted marketing and personalized approaches. The algorithm may require tuning based on the evaluation feedback. Adjustments to the model or data preprocessing help enhance the quality and relevance of the segmentation. Finally, the refined model is trained again with the improved data or parameters. This iterative process ensures that the model becomes more accurate in identifying customer microsegments over time. Let us explore the stages of reinforcement learning using the example of a chess-playing agent. The process begins with setting up the environment, represented by a chessboard. This environment defines the context in which the agent will learn to play chess. The agent, acting as the learner, observes the chessboard and decides on moves based on its current strategy or policy. The policy outlines the agent's approach to making decisions. It specifies how the agent selects actions based on the state of the chessboard. The agent then takes an action, making a move on the chessboard according to its policy, which influences the game's state. After taking action, the agent receives feedback in the form of rewards or penalties based on the outcome of its move. This feedback is essential for guiding future decisions. The agent's performance is evaluated based on the rewards collected. This assessment helps determine if the actions taken were advantageous in the context of the game. Using the evaluation results, the agent updates its policy to enhance its strategy. This update process is crucial for learning and adapting to the environment. Finally, the agent undergoes multiple iterations of this process, continually refining its policy and improving its chess-playing abilities over time. This iterative training enables the agent to become more proficient and effective in playing chess. And finally, we will explore the stages of generative AI using the example of text generation. The process begins with defining the problem. In this case, the goal is to create a text generation model capable of producing coherent and contextually relevant text based on specific prompts. Next, relevant data is collected from various sources, including books, articles, web pages, and other texts. This diverse dataset is essential for training the model to understand different writing styles and contexts. Once the data is gathered, a generative AI model, such as GPT, is selected. This model will be trained on the collected data to learn how to generate text effectively. After training, the model generates text based on the input prompts. This stage showcases the model's ability to create new content by applying what it has learned from the training data. The generated text is then evaluated for quality and relevance. This assessment helps determine how well the model meets the initial problem definition and whether it produces useful and coherent text. Based on the evaluation results, the model may require tuning. Adjustments to the model's parameters or training process can enhance the output quality and relevance of the generated text. Finally, the model undergoes retraining with updated data or parameters. This iterative training process enables the model to continually improve its performance in generating high-quality text over time. In this segment, we will explore real-world examples of AI applications across three key industries: healthcare, finance, and retail. We will discuss how generative AI and general AI are transforming these sectors, starting with healthcare. In the healthcare industry, AI technologies are significantly enhancing diagnostics, patient care, and operational efficiency. For instance, generative AI is utilized to create synthetic medical images for training healthcare professionals, improving diagnostic capabilities while preserving patient privacy. A prime example is NVIDIA's Clara platform, which generates synthetic CT scans to aid in radiology workflows. On the other hand, General AI applications, such as those developed by Google's DeepMind, analyze medical images to detect diseases like diabetic retinopathy or various cancers, often outperforming human radiologists in accuracy. These advancements illustrate the profound impact AI has on improving healthcare outcomes and operational effectiveness. Now, let's turn our attention to the finance industry, where AI technologies are transforming operations and customer interactions. In generative AI, automated financial insights are produced by analyzing market information using AWS Comprehend. This tool processes data from news articles, financial reports, and social media to generate actionable insights, allowing organizations to quickly understand market trends and make informed decisions. For general AI, Azure Machine Learning is used for credit scoring and risk assessment. Financial institutions employ this technology to develop models that evaluate customer payment histories and behaviors, accurately assessing creditworthiness. This approach streamlines loan approvals and minimizes lender risk through data-driven decision-making. Next, let's explore the retail industry, where AI is revolutionizing marketing strategies and customer engagement. In the realm of generative AI, Azure OpenAI is utilized to create personalized marketing content. Retailers can generate tailored marketing messages and product recommendations based on customer preferences and behavior. By analyzing data from past purchases and browsing history, the AI produces content that resonates with individual customers, enhancing engagement and driving sales. For general AI, AWS Forecast is applied in credit scoring and risk assessment. Retailers leverage this tool to analyze customer data and predict creditworthiness for financing options like buy now, pay later services. By evaluating historical transaction data and customer behaviors, AWS Forecast helps businesses assess risk and make informed lending decisions, ultimately improving customer satisfaction and trust. Adopting AI technologies presents organizations with several challenges that must be addressed to ensure successful implementation. Key challenges include data privacy and compliance. Navigating complex data protection regulations while securely handling personal data is crucial for maintaining trust and avoiding legal repercussions. Bias and ethical considerations. AI models can unintentionally perpetuate biases present in training data, leading to unfair outcomes. Organizations need to implement strategies to identify and mitigate bias to promote fairness and ethical AI use. Skills gap and integration. The shortage of skilled professionals capable of developing and managing AI systems can hinder adoption. Additionally, integrating AI solutions with existing infrastructure may pose technical challenges. Cost and change management. Implementing AI can require significant investment, even in cloud environments. Effective change management strategies are necessary to address employee resistance and foster a culture of acceptance towards AI technologies. What are your next steps in leveraging cloud AI to transform your business? Think about how you can implement AI solutions and address challenges to drive innovation and growth in your organization.